Welcome to the start of a course whose subtitle might well be In Search of the Ultimate Scientific Instrument. Now, modern science from its beginnings has been associated with the use of increasingly complex instruments in order to discover the hidden secrets of nature, that nature's secrets would be revealed through using instruments designed specifically to uncover them. For example, right at the beginning of the modern science in the 17th century, we think of the telescope and the microscope and the air pump, about which we'll be talking more later. But we're more familiar in our time with mammoth particles accelerators that smash atoms, and the atomic force microscope that allows us to visualize atoms, gene sequencing machines, space-based observatories, etc. These are the overt instruments. These are the obvious instruments that scientists use in order to discover the hidden secrets of nature. But there is a fundamental instrument, perhaps the most fundamental instrument of all, that is itself hidden and that in fact is extraordinarily elusive. And that instrument is scientific reasoning itself. How do scientists reason in order to construct the theories that they construct? How do they come up with the theories that they formulate, invent, create? What is the basis for their claims that they know that these are truths about nature? This is a fundamental aspect of science that tends to be ignored, especially in the recent popularity of books about science, many of them by quite eminent scientists. There is a fascination with what scientists know. String theory, for example, the Big Bang theory of the origin of the universe, or the nature of DNA and molecular biology. There have been a raft of popular books about what scientists know. But to the best of my knowledge, there's not a single one of these popular books that focuses centrally on the question of how scientists know what they know. What is the basis of claiming that this theory is true? What does it mean to say that a scientific theory is true? And how seriously should we take that claim? We, especially, who do not understand the theory, we non-scientists who don't understand the theory, how shall we accept the claim by the science community that these theories are true? This is very important to us, the general public, for a number of reasons, not least because science matters in our society. Scientific knowledge matters in our society. Because science works in some quite obvious and practical way, because over the last 200 years especially, science and science-based technology and technology that became entangled with science in the course of the 1800s and 1900s became the source of wealth and power, commercial power, military power, social power, political power. Science has become deeply entrenched in government institutions, commercial institutions, social institutions, and public perception, the public perception that science is very important. And of course, it certainly is important. Industry, especially in America in the post-World War II period, industry, our economic well-being is keyed to a continuous string of innovation, which means to a continuous stream of new scientific and technological inputs that will translate into new innovations that will keep the economy growing. And the government, of course, has, in the post-World War II period, become a sponsor of science to the tune of tens of billions of dollars a year in research, compared to before World War II, when the federal government spent almost nothing on scientific research. After World War II, tens of billions of dollars a year, a good deal of that for military-related, but quite a bit of it also for pure science, so to speak, basic scientific research, on the view that basic science is the seedbed of technological innovation, a theme that was built into the report at the end of World War II by Vannevar Bush, who was the head of the Office of Scientific Research and Development of the federal government during the war, which argued that we needed to continue to invest in science in order to generate the technologies that would secure the national well-being militarily, and that would create a continuing basis for economic growth and prosperity economically. So science is deeply entrenched in our society, and therefore it matters how we act towards scientific knowledge and how we assess scientific knowledge. It is also increasingly the case that scientific knowledge is a major factor in public policy issues: global warming, stem cell research, energy policy, pollution policy. How shall we take the scientific input to these public policy debates? How seriously should we take them? So these are some of the reasons why the question of how scientists know what they know is quite a serious question and quite an important and practical question. And it's quite amazing that it has attracted, relatively speaking, so little attention, almost no attention from the general public. And as we'll see, it has a long history that is quite intellectually fascinating, but also reveals how the answer to that question, how the answer to the question of how scientists know what they know, has in fact had a considerable social impact over the last 400 years. Let me step back for a moment and present a puzzle. Entering the 1960s, modern science was about as deeply entrenched in society as one could imagine it would possible for it to be. It was riding high. And yet, starting in those very 1960s, a very broad, hostile criticism of science began on a very broad front: on a political front, on an intellectual front, and on a religious front. Starting in the 1960s, the anti-establishment protest movements, associated primarily but not exclusively with the Vietnam War protesters, attacked science and technology politically for having been co-opted by the military and commercial establishments. Now, this critique was very hostile, but it did not challenge the validity of scientific knowledge. What it challenged was that the ethics and the morality of the practice of science and technology in Western societies, that scientists and engineers had sold out to the military and commercial establishments, and instead of working for the benefit of humanity, they were working for the benefit of the military-industrial complex, for commercial corporation profit, rather than thinking in terms of the well-being of humanity. The intellectual critique, independent but concurrent with this political critique, was based on the idea that scientific knowledge could not be explained by saying that, well, what scientists do is to collect facts, analyze them logically, and out-pop truths about nature. Beginning in the late 1950s and early 1960s, a stream of books were written, quite often by people trained in the physical sciences who became interested in the history and philosophy of science, which argued that the historical record made it really unequivocal that scientific knowledge incorporates judgments that are not strictly logical or factual. And because these judgments are not reducible to logic or to facts, then scientific theories are not unique accounts of reality. They do not converge on a correct description of reality, but in fact are interpretations of experience. Again, concurrently and quite independently, a number of French intellectuals, especially Michel Foucault and Jacques Derrida, launched an even broader critique on the concept of objectivity and on the concept of knowledge generally, not just scientific knowledge, in which they argued that all such ideas and all such concepts are historical, are ideological. They reflect specific perspectives on experience, and in particular, the perspectives on experience of the dominant class in society at a given time. That some of our most cherished concepts that we think of as value neutral, like objectivity and knowledge and truth, in fact are the expression of cultural prejudices. And of course, they argued this with some cogency. They didn't just claim that it was the case. Foucault used a particular method that we'll be talking about later in the course. Derrida, a different method. We'll also be talking about that. But the important thing is that this broadened the intellectual critique of scientific knowledge because it dumped the problem of scientific knowledge into the more general problem of knowledge, which was now being challenged, that objective knowledge is not really possible, Foucault and Derrida argued. The convergence of the critique of scientific knowledge and the broader critique of knowledge generally led in the 1970s and 80s to what I'm going to be calling postmodernism, a movement which rejected the fundamental thesis of modernism in Western culture, the fundamental thesis of the modern period, which is that reason is objective, value neutral, and it is the universal means by which human beings can reach truth, can resolve their problems, can improve the human condition. This is the age of reason idea that we'll be talking about, the Enlightenment idea in the 18th century, the modern project of using reason as the tool or instrument by which we will achieve truth and we will overcome the obstacles to human well-being, was fundamentally trashed by the postmodernists. And this led in the 1990s to, in fact, something that was called the science wars, as we will see later on in these lectures, that this manifest recognition that there was, in fact, a kind of intellectual war against the traditional view of science. The third critique, well, we saw the political critique, the intellectual critique. The third critique of science was a religious critique. Quite surprising to intellectuals that had pretty much in the 1960s and 70s written religion off as a spent force, the resurgence of fundamentalist religion in the United States, especially fundamentalist Christianity, led to an increasingly militant stance on the part of fundamentalists against those scientific theories that challenged religious teachings. It wasn't a question of just resenting the scientific theories. Creationism and the successor intelligent design controversies actually challenged the validity, the scientificness of scientific knowledge, challenged the truth of scientific theories, and argued that their ideas were equally scientific and deserved to be taught on a parallel basis. So this is really quite fascinating. Where did this this criticism of science on the political front, on the intellectual front, on the religious front, how does it square with the popularity of science, the unprecedented public support for science, and the role that science increasingly played in Western culture, in all developed societies? In fact, science and technology is an index of how modern, how developed a society is. I want to argue in the course of this course that the science wars, broadly speaking, this hostile criticism of science that emerged in the 1960s and became increasingly virulent in the 70s, 80s, and 90s, that the science wars are symptoms of a much deeper conflict, an unresolved conflict internal to science. And that this internal unresolved conflict is, in fact, a reflection of an ambivalence within modern science itself of what the object of scientific knowledge is, of how it is that scientists come to know, and what it is that they know when they say that they know. When they say that evolutionary biology is true, that the general theory of relativity is a true theory of gravity. What is it that they mean by that? There is an unresolved ambivalence within the scientific community as to exactly what that means. An ambivalence that has persisted, even though, as we will see in the course of these lectures, scientists have been aware of the conflict, have been aware of the ambivalence right from the beginning, from the 17th century, and repeatedly subsequently. And the ambivalence has remained, which raises a question in its own right. Well, what does that signify? If the ambivalence is there after 400 years, it probably is symptomatic of something fundamental. Now, bear with me just a moment here, because there's one level deeper that I want to go. This internal conflict within science over the nature of scientific knowledge, let's call it the knowledge problem within science. What does knowledge mean within science? Is itself embedded in a 2,400-year-old war in Western philosophy over the meaning of the terms knowledge, truth, reason, reality. For since the time of Plato, at least, but certainly since the time of Plato, Western philosophers have been aware of the need to choose between two positions on the subject of the meaning of such terms as knowledge, truth, reason, and reality. In Plato's dialogue called The Sophist, Plato talks of the battle between the gods and the earth giants. It's a battle. It's a war over who gets to define philosophy, who gets to define reason, knowledge, truth, reality. On the side of the gods, so to speak, this is, of course, Plato and Socrates' side. On the side of the gods are those who hold that knowledge is absolutely distinct from belief or opinion, that there is a qualitative difference between knowledge on the one side and beliefs or opinions on the other. Knowledge refers to that about which one cannot be wrong. Beliefs and opinions refer to that about which one could be wrong. That's why they're called beliefs and opinions. Knowledge is not a matter of belief and opinion. Knowledge is what is true. Knowledge is necessary. That means it must be the way it is. It is that about which you cannot be wrong. It must be true. So truth is necessary. Knowledge refers to that which is certain. There's no probabilities involved. Knowledge is certain. This is a theme that Plato brought to the forefront of Western philosophy, and Plato's vision, in one form and another, has dominated mainstream Western philosophy. Knowledge is universal, necessary, and certain. What we know is timeless. It is universal. It's not a function of, well, the theory works in Athens, but it doesn't work in Sparta. It is timeless. It is universal. It is necessary. It is certain. That sort of quartet of characteristics is going to recur again and again as we look at the knowledge problem within science. Because, of course, modern science claims to be giving us universal truths about nature. And Plato pointed to a body of knowledge that exemplified universal, necessary, and certain knowledge. Lest you think this is a pipe dream, Plato might say. There is a body of knowledge that is universal, necessary, and certain. It's mathematics. And how does mathematics acquire universality, necessity, and certainty? By being strictly deductive in its reasoning. So on the side of the gods, we have a concept of knowledge, truth, reason that is keyed to deductive logical reasoning. And the essence of deductive reasoning is an argument such that when the premises are true, the conclusion must be true. It is necessarily true. It is certain. So you get necessity and certainty, and it turns out that in order to have a deductive argument, you must have at least one universal premise. We're all familiar with such an example of a deductive argument as all men are mortal, Socrates is a man, therefore Socrates is mortal. This says nothing about women. It said all men are mortal. We leave open the question of whether women are or not. The Greeks did not choose to use that as part of their illustration. On the side of the earth giants, well, who are the earth giants? The earth giants were Plato's philosophical enemies, the Sophists. The Sophists were not concerned with timeless wisdom. The Sophists were primarily concerned with action. They were concerned with making decisions in real life situations. And for the Sophists, the word knowledge referred to a species of belief. It referred to those beliefs that are most strongly held in a society at a particular time. Knowledge is a word that we use when we want to say that this belief is not challengeable. This belief is in the bank. And so I don't need to re-examine this. So I'm not going to call it a belief because I recognize that the connotations of belief is I could be wrong about it. But of course, you could be wrong about knowledge also. For the Sophists, the earth giants, as Plato called them, who want to pull these wonderful definitions of knowledge, truth, reason, and reality down from their ideal Platonic form into practical reality, for the earth giants, the characteristics of knowledge are that knowledge is always particular. It has a certain context within which it can be said to be true or false, but it cannot be universal, necessary, and certain. It is particular. It is contingent. That means it is dependent on assumptions that are not themselves known to be true, and it is merely probable. There is some uncertainty always to be associated with what we claim to know. It can never be universal, necessary, and certain. It always has a particularity, a contingency, and a probability associated with it. This is a colossal dispute within Western philosophy, within Western intellectual culture, that has never been resolved. The dominant strain is Platonic. I'm calling it that. It's the side of the gods. But every now and then, the earth giants have popped up to do battle with them. They have never been fully vanquished. And in fact, as we will see with the rise with David Hume's skeptical philosophy in the 18th century, and then American pragmatism at the end of the 19th and beginning of the 20th century, the earth giants argument, the sophist argument, has come back in more sophisticated and, I think, critically defensible form. The important thing for us is to recognize that this battle within Western philosophy was internalized when modern science began in the 17th century, and we will see this beginning in the very next lecture with the fathers, so to speak, of modern science, Francis Bacon and René Descartes, and the focus on methodology in the 17th century at the origins of modern science. We will see that modern scientists, in a sense, the founders of modern science, wanted it both ways. They wanted to be on the side of the gods, and they wanted the knowledge of nature that they produced to be universal, necessary, and certain, to be really true, to be about what was out there beyond experience, not something that was going to change generation after generation because people had different attitudes, different predispositions, different beliefs, etc. But at the same time, they said, all of this scientific knowledge comes from experience. But everyone has always recognized, including Plato, of course, that experience is particular, that experience is always uncertain, that there's a certain unpredictability, a certain uncertainty associated with experience. So how can you go from experience, which is particular, contingent, and probable, to knowledge, which is universal, necessary, and certain? Modern science prides itself on being empirical and experimental, but at the same time, at the end of all of the experimentation comes a universal, necessary, and certain theory. How can you play both ends? And in fact, that is what science has done in a certain sense, and that is why I say that science has internalized this deep conflict in Western intellectual culture over the definitions of knowledge, truth, reason, and reality. And this unresolved conflict within science has made it, I think, effectively impossible to resolve the ambivalence of scientists over the centuries on the question of what is the object of scientific knowledge? Is it reality, meaning by that term something beyond experience, something which is out there that we do not experience but which we know is the cause of our experience, or is scientific knowledge experience? It makes a very big difference. If science is an account of experience that we accept because it works, that's very unthreatening. After all, technical knowledge, engineering knowledge is not controversial. Engineering knowledge works, we accept it, we use it, we go on. Why is the Darwinian theory of evolution more threatening than the theories that engineers use to build bridges? Because the scientific theory claims to be true. Beyond working. It doesn't just work. Yes, it works, and we're very glad that you give us our grants to keep doing our research because you like the way it works. But what we're really trying to do is to understand the truth. Now, you might say, well, look, how can you have a controversy over the definitions of words for 2,400 years? But step back and think about it. In what dictionary would we go to look up the meaning of these words? Who knows what the word knowledge means? Who knows what the word reality means? Who knows what the word truth means? What is the right way to reason about anything? There's nowhere that we did not come with an instruction manual that we can all look into to find out the truth about these matters. We invented the concept of truth. We, human beings, invented the concept of knowledge, of objectivity versus subjectivity, etc. And so it's not a simple matter to say, well, why don't you just go look it up? That's something that we, in fact, cannot do. So in very broad terms, I'm suggesting to you that there is an issue associated with the question of what scientists know and how they know it that is intellectually fascinating, but it is also of considerable practical import in terms of how we should respond to the truth claims that scientists make. Now, let me sketch a little bit about what's going to be coming up in the course. For the purposes of this course, I have adopted a historical approach. We're going to start with the 17th century and move chronologically to the end of the 20th, the beginning of the 21st century, because this approach, in the manner of a movie contrasted with a slideshow, allows us to watch the knowledge problem within science unfold over time. It allows us to see scientists wrestling with this problem, how they dealt with it in relation to new developments in science, how they dealt with it in terms of the reaction of society to claims of knowledge on the part of scientists. So society, especially in the late 17th and in the 18th century, saw science as a sudden new form of truth, rivaling religious truth, and that prompted social reform, because scientific knowledge was perceived to be true, not merely a useful interpretation of experience. And so the historical approach gives us the advantage of letting us see letting a process happen over time. And so I think that is particularly apposite to this kind of a topic. In the 17th century, when, as I said before, modern science was founded, we will see that from the beginning, from Francis Bacon and Descartes to the end of the century, Gottfried Leibniz and Isaac Newton, bracketing the 17th century, that the founders of modern science were almost obsessed with questions of method, which you might think is kind of odd. Why don't they just get down to the business of doing their science? Why are they spending so much time focusing on method? But I think you can almost anticipate that now, and we will see that their focus on method was in response to this knowledge problem that I've been referring to. In the 18th century, it was philosophers who decided that they needed to develop a theory of knowledge that explained how scientists could know what they claimed to know. The perception that scientists really did know, that these men, overwhelmingly, that these men in those days actually knew truths that no one had known before. How could they do that? How could they go from experience to theories that contradicted experience? Everybody can see that the sun moves across the sky, and yet we're told that we are moving, not the sun. How can they do that? So philosophers, and in the course of the 18th century, they formulated two of the three major philosophical traditions in modern Western philosophy. Rationalism is the one that we inherited from Plato, but empiricism and idealism in the 18th century, late 18th and late 17th and 18th century, are direct outgrowths of responding to science as a new body of knowledge. In the 19th century, science really matured, natural science really matured, and scientific theories became unprecedentedly powerful. Not by comparison with the 20th century, but very powerful compared to the 18th and the 17th century. And scientists themselves, once again, had to confront the knowledge problem within science, what these new mathematically abstract theories really were about. And so from the early 1800s right into the 1920s, major scientific figures also concerned themselves with the knowledge problem within science. Since the 1920s, the philosophical community has taken over the knowledge problem within science, and scientists have dropped out. And we'll have to talk about why that was the case and how this has made the science wars of the 1960s as intense and conflictual as they turned out to be. So our focus in the course is going to be on the knowledge problem within science, as I defined it before. And think of these questions. What does it mean to be rational in response to experience? What is rational action? If the sophists are right and action is always particular and concrete, and if rationality is universal, necessary, and certain, then how can you have rational action? And finally, why is this ambivalence still unresolved? We will be exploring these and related questions in the course of the lectures to come.